Hello everyone, my name is Aviad and I'm working at Mobileye. I'm developing a MLIR compiler for automotive cars. Imagine you're driving a car. Let's say from home to work, 30 minutes drive. What do you see? You see pedestrians, you see cars, you see roads, and you see many other stuff that is not related to the driving itself. Still, every second, you need to take some decision about the driving. How do you do it? How a computer does it? Actually, I have 10 minutes, so I can't fit in all the details. But you must understand that time is crucial, and high performance is needed. And for that, we must preserve the cache locality. Or in other words, we would like to reduce the bandwidth between the main memory and the cache. And we are using transformation called tile and fuse, which help us to do exactly that. This allows us to preserve the cache locality, and the key point of my lecture is actually how to plan it in order to reach this high performance. So, sorry. Okay. So some of you may not have heard of what is tiling. So let's start about tiling. Say you have a process unit and you have a main memory, but the process units cannot directly access the main memory. Instead, you have a cache. And the cache is much faster than the main memory, but also much slower.
Sorry.
You
can keep going. Just this.
Okay. So the cache is much smaller than the main memory. What can you do? You can split the picture into small chunks called tiles. And now you can process each tile separately, and once you finish with the processing, you can write it right back to the main memory. And you can do it iteratively until you finish with the whole picture. In addition to that, you can fetch multiple tiles together into the cache and parallel the work. So as I said before, we must reach high performance and preserve the cache locality. So I would like to show you an example of operation called convolution. The convolution gets input, which is big, and relatively smaller input called weights. The key part to understand is that for each output tile, we must use the weights for all the input tiles. So we must preserve the weights in the cache if you want to avoid bringing them back every time. But tile and fuse say much more. Say we tiled an operation. So we can store the data in the cache, and right after, run the next operation and next operation on this tile. Once we finished with all the compute, we can write it right back in the main memory. This is actually tile and fuse. It means take multiple iterations together, tile them together into one loop, and only once you finish with them, you write it to the back memory. Well, I have good news for you. The transform already exists, and it's called tile and fuse. Tomorrow morning, you're going to have a tutorial by Conwar exactly about the transform. I just would like to give you a small highlight about how the transform works. So let's say you have an operation, like the one below, the fully connected, and you tile it. After you tile it, you can fuse and tile the convolution above and the convolution above into the already tiled loop. And the transformation has a control function, and the control function allows you to select which operations to fuse and when to stop the process. But I have some bad news. The selecting of the tile size and which operations to fuse together is not an easy task. And I'm going over some approaches, how to deal with it. The first one is a vertical approach. The vertical approach means that we would like to fuse many operations together as possible, and to fit into the cache, we need to decrease the tile size. This way, we preserve the cache locality. The other approach is horizontal tiling. It means that we would like to fuse less operations together, but increase the tile size. This, for example, allows us to have smaller number of tiles and reduces the control flow because we have less iteration on each on the tiles. But actually, the hard or the good optimization we can do is to find the sweet spot between horizontal tiling and vertical tiling. And this is not an easy task, because once we fuse some operation together, we may not fuse other, and selecting the tile size is not an easy task. In addition to that, we have some other issues like overlapping tiles. Overlapping tiles are tiles that are needed for more than one iteration, and we must consider it when we take the tile size. And as a compiler, we may have scheduling down the road, and scheduling may mean that we will like to hold the tile for more than one iteration. This also affects the tile size. Well, to tell you the truth, every one of us each its own hardware, so it has its own limitation and planning how to tile and fuse. But during the work of developing the planning and analyzation of the graph, we understand that something is missing and can also affect others. For example, let's say you selected an operation and you selected a tile for that operation. Once you selected the tile, we couldn't infer how it affects its producers, or the other way around, we couldn't infer how it affects the consumers of the operation. To put it in other words, we would like to know if once I selected a tile for some operation, how it affects the graph. And this will help me to know how to fuse or select the tile size. Well, you can run the transformation and know that, but once you run the transformation, it's already too late. You're already mutating the IR, and it's not good for the planning phase. So we decided to introduce a new interface called Fusion interface. The Fusion interface allows us to do exactly that. It allows us to understand the relationships between the iterations. Once I select tile form operation, it allows you to understand about the operands or the results. And this way, I can analyze the whole graph and select before I start the transformation. Well, there is OpenRFC that was written by my coworker, Amir. Feel free to join and take a look if you believe that you also introduced something like that or saw something like that. Personally, I saw that in IRI project, there is similar way to address the problem, and we would like to put it upstream. So the Fusion interface does exactly that. So to sum up, we saw what is tiling and when it is needed. We saw that there is existing transformation, but the actual part is to plan it and do it the right way and reach optimization, which will allow us to preserve the cache locality and reduce the bandwidth, because at least for us, it's becoming a bottleneck because the compute is fast, but the main memory is much slower. Thank you very much.